Hello there, and welcome again to the second part of lecture 2. Today we talk about the friction, and the friction is the force, one of the type of the forces, of course, which is contact force, is a force that always act to resist the motion of one object to another. So if you have object exist here, okay, and you are pushing on that object, okay, there is here in the contact between these two objects, there is a friction force appear. This friction force, this is normal force, okay, F, and I will name this one as Fs. Fs, okay. This force is applying against the motion that you did, okay, and this one we name it as a friction force. A friction force can exist between two solid surface or between fluids, okay, maybe viscous forces is named. When we walk or run, we are not just like conscious of any friction in our knees or other leg joint. These joints really are lubricated by the synovial fluid. So these two joints, if you see them, they are not have a friction between them when you are moving. Why? Because there is a fluid here. This fluid make the friction is zero, and then you can moving clearly. If, for example, you're getting old, then you will have this fluid will be reduced, and then the pain will be start with you. Even you will do any movement, you will feel the pain because of the friction. And we have two types of the friction. We have just like a static friction and dynamic friction. Okay? Let's start with the static friction. A static friction is just like the beginning of the movement. So it's if you have, for example, any object, okay, you have this object here, and you apply force on it, okay, and it's not moving. When it is starting moving, so I will write start of movement. That means you are in the static friction. If it's just like a continuous movement, that means you are in the dynamic friction. Okay, so if you are seeing any object, you are pushing and it's not moving, and then start moving, that means you are in the static friction. If it's like you are pushing the object and it's continuous moving, that means it's about the dynamic friction. Okay, and just like if we start here, for example, you have this block here, okay, and this block, if you are seeing it, the block is just like we have, if it's at still according to the first Newton of law, we have two forces apply on it. We have normal force apply up, and we have a weight of the block which is applied down, but which one of them is cancelled the other, so there is no force applied on them. Okay, and this is the first set. If there is no force applied in the horizontal direction, this direction horizontally, and the block remain at rest, then the friction force must be equal what? Zero, according to the first law. So there is no horizontal force, so there is no this force, only you have B now, or A or B. So both of them apply up and down, each one cancel each other, the other, according to the first Newton law. It will be the friction force will be equal zero. Okay, if we apply a small horizontal force, now I am applying force, a small horizontal force to the right, and if the block remain at rest, the friction force can no longer be zero. Okay, so when it just you are applying force, the force which is the T force, and still the object remain at rest, that means the friction force equal what? Is not equal zero. Why? Because now this one is cancel this one. Okay, so the net force will be equal zero, and this force, the T force that you apply, it will be cancelled the friction force. So that means the total force will be equal what? Will be equal zero. then that's mean when you're applying a horizontal force on any object and the object is not moving, that's mean the total force will be equal 0 because the object at 0. But the friction force is not 0. The friction force equal to the opposite or the minus of the horizontal force that you applied. And you can see here clearly when the object, when the T is gradually increased, Fs will be increased also. Eventually, when BT become large enough, the block began to slide. Okay, so focus on this word, began to slide. That means start of what? Start of movement. Okay, began to slide, that means start of movement. The static friction force attains a maximum value named maximum static friction. Okay, so experimentally, it's found that Fs maximum, which is the friction force maximum, will have two properties. Will not depend on the, or independent of the contact area, and for a given pair of surface is proportional to the normal force. Okay, so F for a given pair of surfaces, Fs maximum is proportional to the normal force. So Fs maximum is coming from what? Coming from the mu s, which is the constant coefficient, and with the normal force n. Okay, and we will have example. We'll see how it's work. Before that, the kinetic force. The kinetic force is just like when it's keep an object sliding at constant velocity. So it's continuous movement. Okay, as I say, the difference between the static force and the kinetic force, or static friction and kinetic friction, sorry, it means the static friction is the start of movement, where the kinetic friction is the keep of movement. Okay, and is smaller than that required to start movement, and always the kinetic friction is smaller than that required to start movement. So always the static friction is bigger than the kinetic friction. The sliding or kinetic friction is less than always the static friction. The kinetic friction is the same, depend on the normal, and Fk equal mu k, which is the m is constant, mu constant time n. And mu q is the coefficient of the kinetic friction, and it just nearly independent of the velocity, and always is Fk less than Fs and mu k less than mu s. So always the static friction is force is bigger than the kinetic one, and the coefficient of the static force is bigger than the coefficient of the kinetic one. All right. Now, what do we have? We have example, a 50 Newton block on the flat. So you have a flat, you have a block on the flat. Okay, and the normal force is the same as what? Is the in amount is the same as the weight of the block. So N or Fn equal what? Equal 15 Newton. Okay. Horizontal force, a 50 block is on a flat. Horizontal force, if the horizontal force T equal 20 is applied and the block remain at rest. So when there is a horizontal force applied is 20 and the block remain at rest, what is the friction force? As I said, condition, when we have the force, when the object at rest and there is no horizontal force, the friction force will be equal to 0. However, when you apply a horizontal force and still the object on the at rest, that means the friction force will be equal what? Will be equal the same idea, or the same of contact force. So Fs will be equal T will be equal 20 Newton. And F maximum will be equal what? Will be equal 40 Newton. And 40 Newton, which is the add of both of them, equal mu time F. And then mu S, so I want the coefficient. And the block is start to slide when the T increase to be 40. Okay, when the T is increased to be 40, then mu s equal Fs over Fn, which is equal 40 over 50, will be equal 0.8. Then when the when the block continue movement, see continuous movement, that means you are talking about the mu s, mu k, which is Fk, okay, where because the force will be get reduced to 32 over the net force or the normal force, which is 50, the end will be 0.64. And this is the end of the part 2.